So on page 235 yesterday, we kind of finished up with a check, but I felt it was like a little bit rushed. So I do just want to kind of walk through that like it's an example. So remember, we started with our first term and said, okay, which of these are like terms? Well, -5 is a constant, meaning it's just a number by itself. So we could combine it with the 9. So we kind of categorized them here. And then we went to our next term that was different, which was a -3w. So we said it has a w in it, so we're looking with something else for something else with a w in it. And so our circles were our w to the first power terms. And then we had a z term as well. Then we combined our like terms. So we said that -5 plus 9 was 4. When we're combining terms with a variable, we're thinking about combining their coefficients. Since they both have a factor of w, we can combine them. So we said 8 minus 3 is 5, but we had to remember that it was being multiplied by that w there. And same thing for our z terms. We combined our coefficients. So -6 and -4, since our signs were the same, as getting more negative. So we didn't have anything in front of this 5w, but we knew it was positive, so we put a plus here because these terms that are unlike are still being combined here. So in simplified form, it looked like this b here. There's nothing else that we can combine because none of these three things are like terms, okay? Does that make sense for what we were doing yesterday? We were playing with some algebra tiles. Hopefully that helped a little bit too, makes it a little bit more concrete, right? So page 236, we're moving on to example 3 today on page 236. So this wants us to simplify. Well, here we are with fractions. Well, we just learned about how to combine fractions for this reason, right? Ugh. Is that what you're thinking? It's kind of what I'm thinking, to be honest. So we have a terms. So these terms have an a in it. I'm going to circle my a terms. What other term has just an a in it? Good. -1/2 a. So I can combine, see how they're kind of moving them so they're closer? So my circle terms would be 3/4 a plus, or really in this case, minus, plus a -1/2 a. Those are my circle terms. And then I have, maybe we can square these ones. Constants, they're just the number. They don't have a variable in them. There's no letter there. They're constant. They don't change depending on what it is. They stay the same. It's always going to be -2/3 and it's always going to be +5/6. So now we need to combine these fractions. So we have to rewrite our fractions with common denominators. So our square terms were -2/3 and 5/6. So when I'm looking at my coefficients here, since these both have a in them, I can combine my coefficients. Their denominators are not the same, so I can't just add them. What do I have to do before I add these fractions? I have to change the denominators. I have to make them like fractions. So just like we can't combine anything that's not like terms, we can't combine anything that's not like fractions. We have to make our denominators the same. Can my 2 become a 4? Yes. So it'd be easiest to keep my 3/4 the same. How would I make that 2 into a 4? What do I have to multiply by? I'm going to multiply by 2. So what do I do to the top here? Multiply by 2. The reason we can do this is because 2 divided by 2 is 1. We can multiply anything by 1 and it still keeps its identity, right? Lacey times 1 is still Lacey. Carter times 1 is still Carter, right? Jackson times 1 is still Jackson. That keyboard ripped apart times 1 is still that keyboard ripped apart, right? Yep. Keeps its identity when we multiply it by 1. So we're going to say, what's 1 times 2? 2, and we wanted it to be 4, so 2 times 2 is 4, so we do want to double check that. And in this case, are we adding or subtracting, really? We're really subtracting because that was negative. So now we have 3 minus 2 on the top, which is 1 over 4. So that's where they're getting this 1/4 A from. Do you like how they like have it nice and neat as if we don't need room to show our work? Yeah. So that's where they're getting that 1/4 A from. They both had a factor of A in it, so we were able to combine the coefficients. So now we need to combine these here. It looks like we need to change them so they both have a denominator of what? 6. So we've got 5, 6. And we have, how do I make that 3 a 6? Times it by 2. 2 times 2 is 4. And 3 times 2 is indeed 6. So we're adding, but this fraction was actually negative, which means 5 minus 4 is what? 1. And our bigger number was positive, so our answer is positive. So 1/6 then gets added to this 1/4 A. That was difficult, right? We have to think, we went from combining regular coefficients to combining fraction coefficients. Right? So it's good that hopefully these adding and subtracting fractions is pretty fresh in our memories, hopefully. So this we're just rewriting here, 1/4 A plus 1/6. So now here is our check. We're simplifying this. We should be able to combine our M terms, right? So our circles are negative 1/4 M plus 3/8 M. And then we can combine our constants. Some people like to use color. I know that sometimes all we have is one thing, so shaping usually works best for me. But if it helps you see it better to highlight what you can combine, you can definitely do that too. So here I have a 5/6 and a 2/3. Now some of these we have already made into common denominators, right? So I can make something out of 6 here, hopefully fairly easily. Okay. She just went to look for her workbook, she said in the book. Gotcha. All right, thanks. Mm-hmm. All right, so we did already make this here, right? What did we say 2/3 was equal to in 6? We said was equal to 4/6. So we can just bring that down here. Our 5/6 minus 4/6, which is equal to what? 1/6. It's always great to go back and look. Typically, we've practiced making things into equivalent fractions with different denominators, so you could probably go back and see what that fraction is equivalent to with a different denominator in your workbook or in your packet. Now we do need to combine these, but our denominators are different. So how do I make this look like this, or at least have the same denominator? Times it by 2, good. So whatever I do to the bottom, I have to do to the top. So 2 times 1 is 2, 2 times 4 is 8, and this was negative. So negative 2 eighths plus 3 eighths is equal to what? 1/8, excellent. You think you have 3 positive eighths, and 2 of them match up with these to make 0, you have 1 left. What can I not forget that is still a factor here? What were these both being multiplied by? M. So I have to include that here. So now I combined these two to make 1/8 M. And I combined these two. Her Chromebook's right there with that water bottle, but Kelsey. That's Tannen. So now we can combine these two fractions here. And what did we get for that? 1/6. Was this positive or negative? Well, 5 minus 4, our bigger number was positive. So this is still positive too, right? Unless we missed a sign along the way, which I don't think we did. We were okay. So what am I going to put between these two? A plus. Because if I just had a 1/6 here, it's going to look like 1/8 times M times 1/6. But that's not what we want to happen. Okay? So here would be our answer to that check. Woo! There are a lot of examples in this section. Perfect. So I kind of want to, before we move from here, I do want you to look at using those first three examples in your practice. So we're going to jump to page, thank you, 241. And we're going to do numbers 1 through 8. I really, really want you to try these. Remember, right here, if you're not sure what to do on number 1, you can look back to example 1. If you're not sure what to do on number 2, look back to example 1. If you're not sure what to do on examples 2 and 3, I'm sorry, on 3 through 8, look back to examples 2 and 3. Okay? So try these. We're kind of combining like terms together with what we already know. They gave you this nice expression. Remember, this is like 1C plus 0.25C. We can combine our coefficients and we're left with something C. So that's what you're going to do for number 2 as well, okay? So 2 things if you're getting stuck, right? Here, we remembered that there was a 1 in front of anything that's just a letter. That's its identity. There's 1 of them, right? So we said 1 plus this 0 here made this 1 and 25/100. So that's what you're going to do for number 2. Instead of 1C, you have 1R, but you're still going to combine this 1 with the coefficient here and have that times whatever letter you have. In this case, it will be R. Now, if you're getting stuck as you move forward here I would recommend going step by step. So I would say negative y. What else has a y? This negative 16y, right? So I have negative, what's the coefficient of negative y? The coefficient of negative y is negative 1. And then we have negative 16y. So it's getting more negative. So if this is getting more negative, what's negative 1 minus 16? It's getting more negative. So we're at negative 17. Excellent. So that's being multiplied by the y. That's what we're combining here, right? Now if we're looking at the next term, it's a 9z. Mm-hmm. Yeah, I can't wait. So 9z and a negative 25z. 9z negative 25z. I'm combining my coefficients. You can put this into a calculator if you need to, but your signs are different, so you find the difference. 24 minus 9, I'm sorry, 25 minus 9 is 16. So negative 16z. And this was the combination of my squares. And then the only thing I need to bring down, I shouldn't have circled it, is my final term, which is plus 4. Do you see how this shows them all being combined? Negative 17y minus 16z plus 4. So we're combining coefficients. Go through. What are you going to combine next? Don't just stare at your paper. Try them.